We take water completely for granted, right? You turn the tap, it flows. You drain the sink, it's gone. But the sustainability accounting behind the massive infrastructure networks managing all of this, well, it's incredibly precise. Let's dive right into decoding the SASB sustainability standards for water utilities. But before we look at any actual environmental or social metrics, we have to ask ourselves a pretty fundamental question. What exactly makes a water utility? I mean, how do we categorize these complex systems? It's honestly not as simple as just pointing at a pipe in the ground. Okay, so our absolute baseline definition for the water, utilities, and services industry, which SASB classifies as IFW, focuses on the entities that actually own and operate these systems. We're talking about the whole life cycle here: the sourcing, the treatment, the distribution, and the eventual wastewater management of the water we rely on every single day. Here is our quick roadmap for this explainer. First up, defining water utilities. Second, we'll draw a hard line on the classification boundary. Third, resource operations and efficiency. Fourth, water quality and affordability. And finally, climate and network resilience.
All right, Section 1, defining water utilities. Let's look at what these entities are actually doing on a daily basis.
The daily life cycle of water management essentially means these entities are pulling water from a source, like groundwater or a reservoir, treating it so it's entirely safe, and then distributing it out to residences, businesses, and governments. And then comes part 2, collecting the wastewater. That means sewage, gray water, and stormwater runoff. They have to treat all of that before safely discharging the effluent back into the environment. Section 2, the crucial classification boundary. Now, this right here establishes the single most critical distinction in the entire SASB infrastructure sector. You can kind of think of this as a metaphorical fence. On one side, you have the architects and the construction crews with the hard hats physically building the systems. Those guys strictly fall into the engineering and construction services industry, or IFC. But on the other side of the fence, you have the utilities actually turning the valves, sourcing the water, and operating those systems day in and day out. That is IFW. So the major takeaway here is that IFW completely excludes infrastructure design and development. If a company is out there building an aqueduct or pouring concrete for a brand new treatment plant, they are engineering and construction. But if they're managing the actual flow of water through that plant and billing customers for it, they're a water utility. This boundary is absolutely crucial for investors so they know exactly which sustainability metrics apply to who. Moving on to Section 3, resource operations and efficiency. Now that we're strictly looking at operations, let's see how we measure day-to-day sustainability. So moving and treating millions of gallons of water, it takes a massive amount of power. In fact, energy is typically a utility's largest operating cost, right after purchased water, labor, and chemicals. Because of this, SASB requires them to disclose their total energy consumed in gigajoules, along with the percentages of grid electricity and renewable energy they use. Using grid energy inefficiently creates Scope 2 greenhouse gas emissions and really exposes the utility to future price spikes. And you can see how these energy and distribution metrics are formally codified right into the SASB reporting matrix for investors to track. But beyond just energy, there is another huge efficiency factor on this matrix to consider, which is the distribution network itself. A major metric here is something called non-revenue real water losses, which is essentially a highly technical way of saying physical water squandered through leaking mains, failing connections, or tank overflows before it ever even reaches a paying customer's meter. Not only does this waste a precious natural resource, but it literally wastes all the energy and chemicals that went into prepping that water in the first place. To combat this, utilities have to track their water main replacement rates, because efficiently replacing an aging main as part of a planned maintenance schedule, rather than just slapping a patch on a pipe after it unexpectedly bursts, can drastically reduce these losses. It's a win-win, really. It improves the utility's financial returns and conserves resources all at once. Section 4. Water quality and affordability. Let's see how this operational boundary applies directly to the end consumer. Reliable, clean water access is widely considered a basic human right, so water utilities are in this unique, highly scrutinized position. They have to balance funding their massive infrastructure with affordable rate structures for everyday folks. SASB asks them to report their average retail water rate, but more importantly, to track residential disconnections for non-payment and how many of those households get reconnected within 30 days. But you can't just look at a utility in a vacuum. The standard actually requires analyzing external affordability factors, things like median household income, poverty rates, and employment rates in the specific territory they serve. If a utility's costs are so prohibitive that they inhibit basic access to water, they are basically inviting massive community backlash and strict regulatory action.
And on the quality side, they are tightly monitored. Utilities must report any incidents of noncompliance for both the drinking water going into homes and the treated effluent going back into the environment. Exceeding limits or violating World Health Organization guidelines, that can mean severe regulatory penalties and a total loss of community trust. Plus, they need strategies for managing emerging concerns. Think pharmaceutical residues or chemicals that aren't fully regulated yet, but are definitely on the horizon.
Finally, Section 5, Climate and Network Resilience. Let's look at how these operators future-proof their grids against a changing environment. To measure long-term environmental risks, the framework tracks how much water is sourced from regions with high or extremely high baseline water stress, and how heavily a utility relies on purchasing water from third parties. Now, the number 100 is super important here. SASB specifically wants to know the capacity of wastewater treatment facilities located in 100-year flood zones. Just think about the sheer disaster if a facility handling raw sewage located in an area with a 1% chance of flooding every year becomes completely inundated during an extreme storm or rising sea levels. When intense rain overwhelms a facility's capacity, it causes a sanitary sewer overflow, or SSO. This is where untreated effluent goes straight into the environment. It's as bad as it sounds. Utilities have to report the number and volume of these overflows, plus any unplanned service disruptions, categorized by exactly how long the disruption lasted. You can't just cross your fingers and hope for the best here. Utilities have to detail their real-world risk management strategies. That means investing in redundant systems, diversifying water sources, using advanced global climate models to predict weather impacts, and increasingly treating wastewater to a level where it can actually be safely recycled and delivered back to customers.
So, understanding the strict operational boundaries of these utilities, remember, they are the day-to-day operators ensuring the flow, not the builders, allows us to truly measure their sustainability. And it brings us to the ultimate question. As the climate shifts, is your local water utility resilient enough? It definitely leaves you wondering how well our own local grids are really adapting to these massive pressures. Thanks for joining me on this explainer, and keep asking the right questions.